All right, we're going to start in lesson 4.2 this morning. We just finished 4.1 where we did the distributive property, and we're going to continue on with starting to get into algebra. We're on page 269 of your book, if you'll turn there. The addition property of equality. If you look in the middle of the page, there's a definition section, and it says a solution for an equation is a number that, when used in place of the variable, makes the equation a true statement. Math books have a distinct way of making things that are very simple, very complicated sounding. So let's explain this in everyday language. What they're saying is that when we have an equation, there is a number that we can put in there for x that will make that a true statement. And that number obviously is a 4, because 4 plus 3 equals 7. Therefore, 4 is a solution to x. So that's all we're talking about when we're talking about a solution. Alright, so if we look at example 1 there, we've got an equation 3x plus 2 equals 17. And the question is x equal 5 a solution to that? So what we're going to do, we're going to take whatever value they're asking you to determine, and we're going to put that in for our x. Notice how I put a parenthesis around that 5. I always do that because sometimes this number is going to be negative. And if it is negative, and I put 3, you could confuse that as 3 minus 5, or even if I put a multiplication here, you never put a sign or an operation symbol, a multiplication sign, and another operational symbol, minus or negative, next to each other. So you put a parenthesis around that, and you don't need to show the multiplication sign, but it does show that you're taking whatever number x is and plugging it in here, whether it's positive or negative. It just simplifies everything. So that's 15 plus 2 equals 17, and as you can see, 17 equals 17. So that's a true statement. So x equals 5 is a solution to this equation. And one of the things as you get into algebra, you'll find out that sometimes there's more than one solution. Sometimes there's an infinite number of solutions, meaning there are billions and billions of solutions to solve this. Alright, so if we have 7x plus 4, and we say that that is equal to 3x minus 2. And let's say that we're going to make x equal to negative 2. Alright, if I do that, then what I'm saying is I'm going to plug a negative 2 in here. And I'm going to put a negative 2 in here. Then I'm going to use my PEMDAS, order of operations, to see if this is a true statement. So if this side of the equal sign is equal to this side of the equal sign, therefore obviously they're equal, and we can say that x equals negative 2 is a true statement. Let me change pins here. Alright, so 7 times negative 2 is negative 14 plus 4. 3 times negative 2 is negative 6 minus 2. Well, negative 14 plus 4, if you remember your addition of positive and negative numbers, you take the difference between the two, because the signs are different, put the sign of the largest number on there. So the difference is 10, and the 14 is larger than 4, so it gets the negative. Negative 6 minus 2, or negative 6 plus negative 2, if you prefer, is negative 8. Alright, that being the case, this is not a true statement, so we put a line through here to show that they're not equal. Second part of this lesson, middle of page 270, it has the addition property of equality. The addition property of equality basically says that if we have two numbers and we say that they're equal, obviously they are, and we add another number to this side, they're not equal. But if we add that same number to the other side, they are equal again. Although 3 equals 3, has changed to now it's 5 equals 5. The fact that you're concerned about is, are those numbers still equal? I don't care what's over here and what's over here. The question is, are they equal? Is this a true statement? If it is, then you can do that particular procedure. So, for example, if I have x plus 4 equals negative 2. Well, what does this x have to be in order to make this a true statement, or equal to negative 2? Well, it ends up being negative 6. Negative 6 plus 4 equals negative 2, because we're adding two numbers. The signs are different, so we take the difference between 6 and 4. We put the sign of the largest number on there, and that is a true statement. So negative 6 makes this statement true. Therefore, negative 6 is a solution for x. Well, you get into some problems here, some equalities or equations where it's not so easy just to look and see that negative 6 was the right answer. So what we do is we call it isolating the variable. Let me write that up here. Isolating the variable. I will use that term a lot from now on. What that means is, on the equation I had up here before, x plus 4 equals negative 2, isolating the variable means that I am going to remove all numbers from one side of the equal sign so that the variable, the x, is all by itself. It's isolated. There's nothing else over there with it. So that's what I mean by isolating the variable. Getting the variable, or the x, or the y, or the z, or whatever it is, all by itself on one side of the equal sign. So, to do that, let's start out with x minus 3 equals 5. Now, I'm going to be doing some of the problems on this lesson a little bit different than the book, although I'm on top of page 271, example 4. This one will be just like the book. Now let's take the isolating the variable and the addition property of equality that we talked about earlier, where you can add a number to one side and you add it to the other. You can do that because it continues to make this equal. Well, let's take both of those and put those together. I'm trying to get this x all by itself. I don't want this minus 3 over here. So what I'm going to do is I'm going to find a number that I can add to this side and add to this side, okay? Which I can do that according to the addition property of equality, so that this minus 3 disappears. So I'm going to try to do the proverbial kill two birds with one stone here. So the way I do that is whatever sign I have in front of the number, in this case it's a minus 3, what I'm going to do is I'm going to add a 3 to this side. Because what is negative 3 plus 3? Well, it's 0. That means this whole thing is going to cross out and I'm just going to have my x left. So what I'm trying to do is I'm trying to get rid of all the numbers, add or subtracted to the x, get rid of them so that I can find out what x equals. Because if I get rid of this, I now have just x over there, and x equals something. But according to the addition property of equality, if I add something to one side of the equal sign, I also have to add it to the other. So, if I do that, these become 0. 5 plus 3 becomes 8. So now all I have on this side is an x, and all I have on this side is an 8. So x equals 8. So 8 is my solution. Let's see if that works. Let me take that 8 and plug it back in here for x and see if it works. 8 minus 3 is 5. Does that equal 5? Yes, it does. So this is a true statement here, a true solution. X equals 8. So that's what we're going to be doing in this section. So let's continue along with some of this. The next example is y plus 4 minus 6 equals 7 minus 1. Alright, so first thing we're going to do is our combining like terms, putting things together that are similar. And we'll finish this problem on the next video on 4.2b.